This is the curve then. Show that any point PQ on this curve, the gradient is given by this. Show that the tangents at this and this point intersect on the x-axis, and show that these two equations are parametric equations of this curve. So there's the question then. So it's worth having a go at it before we look at the solutions. Here's the question in summary form. So let's have a look at this now. X squared minus y squared equals 8. We want to get dy dx. So A part 1. X squared minus y squared equals 8. We want to get the gradient, so we need dy dx here. So differentiating 2x something squared, the 2 comes down, power rule, minus 2 times something to the 1, multiplied by the something differentiated, and the constant goes to 0. So divide by 2 all the way through, and we can see that x will equal y times dy dx, and so we can find out dy dx, can't we? Move the y from times to divide, it will be x over y. I've written it down from right to left. At the point PQ, this will equal p over q at the point P and Q, when x is P and y is Q. So there's A part 1. Part 2. Show that these tangents intersect at the x-axis. So that means we need to show the y value at the point of intersection of these lines is 0, don't we? So we need the tangents at PQ and the tangents at P minus Q. So at PQ then, the equation is y minus the y value there is equal to the gradient of PQ times x minus the x value, which is P. Okay, so let's expand this bracket then. We get px over q minus p squared over q. So we need to get x, don't we, really? But y seems an awful lot easier, so I'm going to just stick with y for the moment. So it's px over q minus p squared over q, and move this q over plus q. So I'm going to find both coordinate values, I think, because it's easier to deal with the x first, and then from x find y. So at p minus q now, y minus this value becomes plus q is equal to the gradient. Well, the gradient is x over y, so it'll be p over minus q. At this point is the gradient, x minus the p. So that tells us that y is equal to minus px over q, and then minus over minus is plus, p squared plus p squared over q, and then move the q over minus q. So at the point of intersection of these two then, the y values will be the same, and we see that px over q minus p squared over q plus q must equal this value. Okay, so let's move them all on one side. Move this over to be here, and we end up with 2px over q, don't we? So it's plus px over q twice. This moved over becomes plus, and we end up with 2p squared over q. And move the q over, we get minus another q, which is minus 2q. The 2's cancel all the way through then, and we end up with x is equal to multiply by q over p all the way through, q over p, well, the q cancels and just one p is left on top. And then we multiply this by p over q, and it will get a q over p rather, minus q squared over p. So there's our x value. Okay, so here then, what does y equal? We need to show that y equals 0. Let's put it in, minus p over q times the x value So that was that. Here, plus p squared over q minus q. So that equals, let's see what we get, minus p squared over q plus, the p's will cancel and one of the q's will cancel and be plus just one q plus p squared over q minus the q here and here. And we can see all these cancel and equal 0. So yes, y does equal 0 and they intersect on the x-axis then. So that was part A2. Show that these two equations, t plus 2 over t and t minus 2, are parametric equations of this x squared minus y squared. T plus 2 over t, t minus 2 over t. Minus 2 over t. So x squared minus y squared then is equal to this squared minus this squared which is the difference between two squares. So we could do that if we wanted. X minus y times x plus y if we wanted, or we could just expand these brackets. Let's do x minus y. So this, take this. This is equal to, I'll just write it here for reference. Okay, so when we take this, this take that, we'll get the t's cancel, and this take that will be 4 over t. When we do this, these two terms take away these two terms, the t's will cancel, and this take away this will be plus. So we end up with that in the bracket, times the x plus y. When we add them, these 2 over t's cancel, and we're left with 2t. So that must equal 8. Which is what we wanted to show for part B. So I think that completes the question there, and that's a rather straightforward way to do it.